Right. Good day again. Our continuation is with Pythagoras Theorem. And we want to set the ball rolling by giving ourselves a little task. We need to write or draw on a square paper or create on a geoboard like I have done a right angle triangle with sides 3, 4, and 5. The shortest is 3 units, 4 and 5 units. We'll need to create squares on each side of the right angle triangle like we have done already, and then compare the squares on each side of the right angle triangle so that we can share our findings with our colleagues. Here on the board I have my right angle triangle with the sides 3, 4, and 5. Now Pythagorean statement or equation or theory says that the square on the longer side of the right angle triangle, which is the hypotenuse side, is equal to the square on the other two sides or the legs of the right angle triangle. That means we have 5 squared is equal to 4 squared plus 3 squared. Can we check to see if that statement is true? 4 squared will give us 16 and 3 squared will give us 9. And so we have that to be equal to 5 squared, and 5 squared is 25. Is that the case? So we have 16 plus 9 will give us 25. And so we have 25 is equal to 25. So the Pythagoras statement is true for the triangle with the sides 3, 4, and 5. So continuing, we will look at Pythagorean triples. These are, yes, we can call them Pythagorean triplets or Pythagorean triples. Now these are 3 numbers that satisfy the Pythagoras theorem. For example, 3, 4, 5. These are called the primitive Pythagorean triplets. Now what happens is what we have just looked at, that the longest side squared will give us the sum of the square of the other 2 sides. So what other numbers can give us these triplets? What combination of numbers can give us Pythagoras triplets or Pythagorean triplets? One other one we can look at is 5, 8, and 12, 5, 12, and 13. 5, 12, and 13. Basically, when you have the primitive Pythagorean triplets, you can generate more of them. For example, any multiple of the first one can give us another triplet. So multiplying each of these values in the triplet by 2, we will have 6, 8, and 10. And that will give us another set of Pythagorean triplets. We can do a similar thing and multiply the numbers by 5. What shall we have in that case? We will have 15, 20, 25. And that will give us another set of Pythagorean triplets. Now with the primitive one, we have quite a number of primitive Pythagorean triplets. Now we are calling them primitive because they help us to generate more of the Pythagorean triplets. So this is a primitive Pythagorean triplet, and yet we can use it to generate more of the Pythagorean triplets. And so if we take this other primitive 1. Can we generate some more? Yes, we can. Multiplying that by 2, what shall we have? We'll have 10, 24, 26, and that gives us another set of Pythagorean triplets. Try your hands on another set from that primitive 1, and let's see what you will have. You can share with other colleagues and see how well you are faring. Now we can generate as many Pythagorean triplets as possible. Now the essence of doing this is to be able to work out Pythagorean problems with little or no struggle. And so let's take a look at what happens in the case of odd-numbered Pythagoras triplets. This set begins with the number 3. That's an odd number. So let's see how it works out for the other numbers. If we square this number 3, what shall we have? 9. And so 9, you divide 9 by 2, what do you get? You get 4.5. Now 4.5, what's the closest whole number to 4.5? It's 5. Good. So our next number in that pair will be 5 and 4. A number above, and then the next whole number above, and the next whole number below your answer, 4.5. Let's try it for this one. We have 5, 12, 13. Square the number 5. What do you have? We have 25. 25 divided by 2 will give us 12.5. What's the whole number closest to 12.5? 12, and the other one is 13. And so that is how the primitive Pythagorean triplets can help us deduce more triplets that will help us in solving our objective questions for that matter. Let's find the value of A and X with the diagrams we have on our slide. And so with these two right-angle triangles, we want to find the value of A. Finding the value of A, we realize it's occurring on the one side of the right-angle triangle, on one of the legs of the right-angle triangle. And so we can quickly take a look at our Pythagorean triples. See where we have a combination of 4 and 5. The third number will automatically give us the value of A without any calculations at all. So coming back to our Pythagorean triple, the set that gives us that combination will be 3, 4, and 5. And so our A without any calculation will be equal to 3. We can, however, calculate for A if we so desire without using the Pythagorean triple approach. Coming to the second one, our right angle triangle has the two legs with values x and 12. The hypotenuse side has a length 13 units. And so, checking again from my Pythagorean triplets, we have a combination 3, 12 and 13. And so the side we are looking for will be 5, based on the fact that the triples that coincides with what we have in our diagram will be 5, 12, and 13. Now with a little trick we're trying to look at, trying to get other numbers that go with the first number. We can look at it from the reverse side, where we have two of the numbers like we have here, 4 and 5. How do we get the third number without any calculation? We can do that by, first of all, adding the two numbers. Add the two numbers and find the square root of the number. Now we have seen the trick that works for the odd-numbered Pythagorean triples. Let's look at what happens in the case of the triple beginning with an even number. So if we have 8, 15, 17, what is the trick that goes with the combination, the set of three numbers that make the Pythagorean triple? The first thing you need to do is that first number divided by 2. So we have 8 divided by 2 giving us 4. Square the number 4. You will get 16. To get the other two numbers, take a number 1 less than the 16 and 1 more than the 16. And that gives you the other two pairs. Let's take another example. 12, 35, 37. Am I right? So we take the number 12, 35, 37. What happens is that we would divide 12 by 2, and that will give us 6. What is 6 squared? We have 36. And so one number less than 36 will give us 35. And then the number more than 36 will give us 37. And that gives us another triple. And so with that, we should be able to generate more from the primitive Pythagorean triples. So these are all referred to as the primitive Pythagorean triples because they can help us generate as many more triples as we want, as possible. Now for more trial, you will need to pose more problems on right angle triangles like we have here, and then make an attempt to solve them either by the quick method using the Pythagorean triples or by calculation applying the Pythagorean equation to solve those problems. You can share your findings or your contributions on the comments page, or you subscribe for more videos on this topic. And then for your questions, you are free to ask online in the classroom, on Google Classroom, or any other network that is available to you with your tutors. Thank you very much.